Test for review. There are 20 questions. I will do non-repeated type of questions only here. The first question is find the inverse of the relation. Whenever you have a relation, finding the inverse means just switch x and y coordinate of the relation. So here, as you can see, the first one has 0 comma 2. That becomes 2 comma 0. So parentheses 2 comma 0 comma, second one has 1 comma negative 6. That becomes negative 6 comma 1. And then third one, negative 3 comma negative 2. Fourth one, negative 5 comma positive 5. So where's the switching x and y coordinates from the relation? Is this a one-to-one function? Definitely it's a rational function. It's a reciprocal function, so it's supposed to be one-to-one. If you try to plot the graph of reciprocal function, we know it's supposed to be look like this is the graph of 1 over x, and this is the shifting to the left 1 unit. So the graph would not change, so it's a one-to-one function. And how do you find the inverse? So there are steps you need to follow. The first one is write down f of x as a y. So y equal 3 over x plus 1. Now switch x and y. So this equation becomes x equal 3 over y plus 1. And now solve for y. So to solve for y, just let's multiply both sides by y plus 1. That gives us this. And just divide both sides by x. So that is y plus 1 equal 3 over x. Subtract 1. And that will be y equal 3 over x minus 1. So the inverse function, whatever y you got here, that's the inverse function. It's a 3 over x minus 1. Okay, let's go to the next problem. Find the inverse one more time. Write down the function as a y. That's step 1. Y equal 4th root of x minus 7. Step 2, switch x and y in the given equation here. So that becomes x equal 4th root of y minus 7. Step 3, solve for y. For solving for y, we need to get rid of this 4th root. For that, we're going to take 4 power both sides. And that is y minus 7 equal x to the power 4. And if you add 7 here, y equal x to the power 4 plus 7. And this is the inverse function. So this one is x to the power 4 and plus 7. Let me see here. Yeah, that's perfect. Fine. How to plot the graph of this exponential function? We start with the e to the power x. There is a minus, so we know the graph of e to the power x is look like this. And if you want to plot the graph of negative of e to the power x, that would be look like this, which is reflection across the x-axis. And if you add 3, this graph shift 3 units to the up, and if you multiply that by 1/4, you are shrinking it vertically. So the step is reflect the graph of e to the power x first, and then shift it up, and then stretch it. So what is that? Shrink it. So shift up and shrink it vertically. So across the y, this is the first one. Okay, how do you plot the graph? Graph plotting needs a little bit of understanding here. So because there are steps we need to follow. If you distribute this 1/4 here, it would be 3/4 minus 1/4 e to the power x. So what we can do is we start with the e to the power x, and then we reflect it, and then we that is vertical shrinking by 1/4 and stretch reflect it, and then after that add 3/4, which is vertical shifting. Because there are steps you need to follow, you always take the vertical shift at the end. So when you click this graphing tool, choose the exponential function, click it here, and change the base. And the base is already e, so you don't have to make any changes. Click a reflection, and then the vertical shift. Before the vertical shift, the vertical stretching is 1/4, and then vertical shift is 3/4, 3/4. Okay, and by doing that, this is the graph we're going to get. This is not right. What did I do wrong here? Let me check one more time. Here it's a 3/4. Did I choose 3/4? 3/4, vertical shift 3/4, and then stretching is 1/4, and then it's a reflection, vertical shift is 3/4 up, and then shrinking is 1/4. So vertical shrinking is 1/4, vertical shift is 3/4, and then the base is e, and the reflection across the x-axis. That's supposed to be right. Okay. Okay, one more time here. The problem was this is the graph, reflect the graph y equal e to the power x across the x-axis. So I was choosing y-axis, but I was thinking about the x-axis, so this is the right one. And when we click it here, it's a vertical shift 3/4 unit, and then reflection, and then 1/4 of shrinking. That's what we found, and when we check answer, that's perfect. Suppose that 66,000 is invested at 3.5% interest compounded quarterly. So find the function for the amount to which the investment grows after t years, and find the amount of money in account at 0, 4, 7, and 10 years. So problem like this can be done by using compounded n times a year formula, which is I'm going to give you here. A equal P times 1 plus R over N to the power N times T. This A is the future value you are going to get if you invest P amount with the interest rate R, compounded N times a year for T many years. So in this question, the principal is 66,000. That's the invested money. The rate is 3.5, so the rate would be 0.035. 3.5 means 3.5. Divide that by 100, that will be 0.035. Quarterly means there are 4 quarters in a year, so n equal 4, and then this is the function. So find the function for the amount to which the invested grows after t years. So this is the function. So we're going to put the value a of t equals 66,000, and then inside the parentheses it's 1 plus 0.035 divided by 4, which is you can add this and then to the power n times t. N is 4, t is t, so 4t. So that's supposed to be the function. You can do this math here, you can do this calculation, and then you can find let's see, calculator, here you go. This is 0.035 divided by 4, and then plus 1, that is 1.00875. So this is actually 1.00875. So now for finding the value of this function when t is 0, that means its initial amount, which is 66,000. T t is 1. So go here in the calculator, and then when t is 1, that would be, take this to the power 4 and then times it by 66,000. That would be 68,000 and round to the nearest dollar, so it's the 68,340. 68,340. And for the next one, when t is 7, one more time type this 1.00875 to the power, if t is 7, 7 times 4 is 28, because 4 times t. So take this number, times it by 66,000, and then round it to the nearest dollar, which is again 84,233. 84,233. Finally, the 10 years, one more time, 1.00875 to the power 10 times 4, which is 40, and then times it by 66,000. One less 0, what is that? Okay, and that is $95,516. Sorry, $93,516 if you round it to the nearest dollar. That's one of the answer is not right. His score is 60%. I don't know which one is not right, so let me go back and check it. Here, instead of 66,000, I put 6,600. That was the mistake I was doing for sure. Now it's 80%, so still I'm doing some mistake here. So 66,000 and 1 plus r over n. I'm not so sure if they want the simplify your answer, type an expression using t as a variable. That's right. The function for the amount 2 is okay. So r over n, so r is 0.035 divided by 4 plus 1, that's 1.00875 to the power n is 4 times t. This is right. So when t is 0, 66,000 is the first answer. When t is 1, that is power by 4 times 66,000, and that is $68,340. And what is that? That's all. Yeah, round to the nearest dollar. It's a $68,340. And then another one is 1.00875 to the power, it's a t equal 4. So t equal 4 means it's 4 times 4 is 16. So to the power 16 times 66,000, and that's a 75,000. That's not 68,000. I was doing wrong here. Okay, when t is 4, it's a 16. So that's 75,871, 72. 75,872. That was the number I supposed to get. 75,872. So let's check now. Good job. That's 100%. Okay, let's go to the next problem. The exponential function given by h of t equal 80,041.48, where t is the number of years after 2006. So that means t equals 0 in 2006. Can be used to project the number of centenarian. It means, I think it's 100 years people, centenarians, in a certain country. Use this function to project the centenarian population in the country. Centenarian means who crossed 100 years in the country in 2011 and 2041. So this is the function, just to replace t by number of years from 2006 to 2011 is 5. So copy that, just 1.048, 1 to the power 5, because 2011 time is 5 years, times this 80,000 and 41.48. If you times it, it's round to the nearest whole number. So if you round to the nearest whole number, it would be 101,235. 101,235. That's the nearest whole number. Let me just go back. 101,235. In 2041, it is from 2006 to 2041. 2041. How many years are there? 2041 minus 2006. That's 35 years. Okay, 35 years. So you type the very same thing, 1.0481 to the power 35 years, times it by that number 80,041.48, and that's 414,391. 414,391. That's the whole number. That's perfect. Convert to the logarithmic equation. So the conversion formula would be, if you have exponential, you can go to the log. Let's say you have base to the power x equal y, then log conversion is log base b of y equal x. So here in this case the base is e, and then value of x is -6, and then y is 0.0025. so that would be log base e, y is 0.0025, and other side is -6. Log base e means it's ln. You can also write it down as ln. So ln of 0.0025 is -6. You can also verify this thing using a calculator. 0.0025 and ln of that is approximately -6. Check answer. 100% correct. Go to the next problem. Change it to the exponential thing. Here the base is 4, so 4 to the power comes from the other side of the equation, equal the number comes from this inputs of the log function. So that is the conversion. Again, one more time, log base 5 of 70. Find the logarithm using the change of base formula. Simplify your answer, type an integer or decimal. So this is actually, if you change the base, you can write it down as a log base 570 is actually log 70 divided by log 5. So you have to use a calculator with the log function. So log 70, so you need to put 70 first. So log 70 divide by parenthesis, don't forget to use the parenthesis otherwise, and then type this number and then log. That's how you see the log 5, parenthesis close. So that is actually 2.6397, and if you round it to the 4 decimal place, that's a 2.6397. 2.6397, 4 decimal place. Express as a product, use log properties. You can use first of all, I can write it down as ln 9 to the power 1/3. This root means it's 1/3, and because of the power rule you can bring this 1/3 down here, and you can write 1/3 times ln 9. So this is, as a product, it's 1/3 times ln 9. Okay, express in terms of sum and difference of log function. You can use quotient rule here. Ln 7 on the top minus ln, and everything on the bottom goes down here. And again, because it has so many terms like 5x to the power 5 and y, you can use the product rule, and then you can apply ln 5 plus ln x to the power 5 plus ln y. Read the instruction. Instruction says expressed in terms of sum and difference of log. So here this is ln7 minus ln5, and I can use this power rule. I can bring this 5 down here, and then after minus plus minus, it's a 5 times ln of x minus ln of y. So this is the expanded form, which is ln7 minus ln5 minus 5 ln x and minus ln y. Okay, express as a single thing. It's opposite of the previous problem. So go back and then use a difference and then product and quotient rule. So ln x minus, inside the parentheses, do the work inside the bracket first. So inside the bracket it would be ln x minus 7 times x plus 7. Because there is a plus sign, so that's supposed to be x minus 7 times x plus 7. If you multiply them, it's actually ln x square minus 7 square, which is 49. And because this 3 goes here on the exponent by using the power rule, so that would be ln x square minus 49 to the power 3. And since here is the minus sign, we can use the quotient rule. So it will be ln x over x square minus 49 to the power 3. So the answer is ln and x over x square minus 49 to the power 3. Okay, solve this equation. Whenever it's possible, try to express both sides as the same base. So 625 can be written as 5 to the power, 5 times 5 times 5. 5 times 5 is 25, times 5 is 125, times 5 is 625. So it's a 5 to the power 4. So this problem can be expressed as 5 to the power 7x minus 7 equal 5 to the power 4. Because of the same base, you can just equate the exponent and then solve for x. So that is 7x equal 11, and then if you divide by 7, the answer is x equal 11 over 7. 11 over 7. Okay, how to solve this log? Because there is only one log function, so you can go from log to exponential form. So log base 2 10 plus 3x equals 7 can be changed as 10 plus 3x equal the base to the power 7. Okay, and then now solve for x by subtracting 10. So 3x equal 2 to the power 7, which is 128. So 2 to the power 7 is 128. You can do that math here. 2 to the power 7, which is 128. And divide by 3 because there is a 3 there. So it's a 42 point something. So 128. So based on the answer, what answer they are looking for, type an exact answer in simplified form. So it's 128 divided by 3. 128 divided by 3 is the simplified form. Okay. Rewrite the given equation without log. Without log, the equation is supposed to be this one. 10 plus 3x. 10 plus 3x equal 2 to the power 7. 2 to the power 7. Okay, I did something wrong here. 10 plus 3x. Rewrite the given equation without logarithms. Do not solve for x. Type an equation. Do not simplify. 10 plus 3x equal 2 to the power 7. And then when you... 2 to the power 7 is 128. Minus 10 is 1. When I was solving it, it's 128 minus 10, which is 118. So the answer is supposed to be 118 divided by 3. I forgot to simplify. Okay, how do you solve a problem like this? First of all, try to express the both side as a one single log function. On left side, what we can do is we can use the product rule, so we can express this as a log base 5x times x minus 2 because there is a plus sign. And other side there is a log base 5 8. Because of the same log with the same base, we can say x times x minus 2 is equal to 8, and we can just distribute 8. X squared minus 2x minus 8 equals 0, and if we try to find the factors, which is 4 times negative 2, negative 4 times positive 2 is negative 8, and negative 4 plus 2 is negative 2. So x equal positive 4 and negative 2. These are the two possible solutions, but whenever we're solving logarithmic equation, after finding the solution, we need to check what happens inside the parentheses of log function. Each of these log function, we need to put these values. If we put x equal 4, this is positive, no problem. 4 minus 2 is positive. So 4 is fine, 4 is acceptable. If we put negative 2, that makes this parenthesis inside the parenthesis negative, which is not acceptable because log function cannot take negative input. So the only answer we can accept is positive 4. In 2012, the population of city was 5.37 million. The exponential growth rate was 2.85% per year. Find the exponential growth function. So for the exponential growth function, it's the function, what is that? Okay, the problem like this can be done using the formula like this: population growth, where p of t equal p of 0 e to the power kt. So p of 0 means initial population, t is time, and k is the rate of growth. So in this problem, in this particular problem, which I just click it and it gave me the different numbers here, but the gist is same. The formula is, p t equal p0 e to the power kt. So this is the formula we're going to use. The formula for the population, p of t is p of 0 e to the power k times t. In 2012, so the starting time is 2012. The initial population is 5.89 million, and then rate is 0.0337, because that's a 3.37. Divide that number by 100, and that's what you get this, and t is here. So the exponential growth is 5.89 e to the power 0.0337 t. So that's the function of time. So now for finding the population in 2018, the time difference is 6 years. So replace this t by 6. So let me just go here, and so 5.89. So e to the power, what is e? E to the power 0.0337 times t. So I need to use the parentheses first, so I did the mistake here. E to the power parenthesis 0.0337 times 6 year, parenthesis close. So this calculation does happen inside the parenthesis. If you click it, that's the population, that's the value for this one, and you have to times it by 5.89. So if you do that, this is the population, which is 7.2 million in 2018. Okay, 7.2 million. Now, how about the population of city will be 9 million in about how many years? To answer this question, so one more time, this population is 9 year. 9 million, and then just put the value here and solve the exponential equation. So 5.89 e to the power 0.0337 t. Divide both sides by 5.89, and then take ln. So ln of this number, 9 over 5.89, equals 0.0337 t, and then divide by 0.0337 to get the t, which is time. So that's what I'm going to do. I'm going to divide 9 by 5.89, and I'm going to take ln of that number and divide that by 0.0337, and that will give me the time, which is almost 1 decimal place. It's 12.6 years. 12.6 years. To make it double, what you have to do is instead of 9, just take 2 of p of 0. So what happens is it's a 2 of p of 0 equal p of 0 e to the power 0.0337 t. So you take ln and then 0.0337 t, and then divide both sides by 0.0337. So ln2 divided by 0.0337. So ln2 divided by 0.0337, that gives you the time to make the population double, which is 20.6 years. 20.6 years. Okay. Find the hydrogen ion concentration of a solution whose pH is 5.6. Use the formula pH is negative log H plus. So pH is 5.6. Here the pH is given 5.6. We just have to use this log function here. What is the function? The pH value is equal to negative of the log of hydrogen ion. So how do you find the hydrogen ion? Plug the value of pH, which is 5.6, negative log, and then negative log H plus. So take the negative, and now you can go from log to non-log because the log has the base 10. So it will be 10 to the power negative 5.6, supposed to be H plus. So 10 to the power negative 5.6, how do you do that? 10 to the power negative 5.6, 5.6 negative of that value. So that is actually 2. This e to the power negative 6 means divide that by 1 million actually. So you have to move this number 6 decimal places to the right, 6 decimal places to the right. So when you do that, there will be 5 zeros, 1 2 3 4 5, and then 2 5 1 1. So this is the only number which is matchable. When interest is compounded continuously, the balance is an account after t years is given by this, where P0 is the initial investment and K is the interest rate. Suppose that P0 is invested in saving account where interest is compounded continuously at 6%. So 6% means this K is 0.06, and then rest is rest. So 0.06 t, what is that? This one is the only one where you have instead of K you have 0.06, and then everything else is same. Okay, according to Newton's law of cooling, if a body with temperature T1 is placed in surrounding with the temperature T0 different from that of T1, the body will either cool or warm to temperature Tt, which is the function of temperature, which is the function of time, after t minutes. So how do you calculate the temperature? The temperature is initial temperature plus difference between those two temperatures, e to the power negative k times t. This is the formula we have given. So we need to use this formula to answer this question. A metal pan with a temperature 155 degree Fahrenheit is placed in a freezer with temperature 0 degree. After 15 minutes, the temperature of the pan is 46 Fahrenheit, 46 degree Fahrenheit. Use the Newton's law of cooling to find the pan's temperature after 20 minutes. So here the idea is you need to find out the cooling rate. What is the K? Okay, and we can do that by using this information first. So remember, the temperature, initially the temperature was 155 degree. Yeah. So the initial means the first temperature was 155 degree, and then after 15 minutes, the temperature becomes, after 15 minutes, the temperature becomes 46 degree. And what is the initial temperature? The temperature of a different surrounding, which is 0 degree. So you use this formula. So T at 14 is 46 equal T0 is 0 plus T1 is 155 minus 0 e to the power negative k. Time is 15 minutes. So 15 minutes. So if you solve this, that would be 46 divided by 150 e to the power negative k times 15. If you take ln both side, then negative k times 15 is ln of this number, which is 46 divided by 155, and then just divide both sides by negative 15. That gives you the rate. The rate is, the cooling rate is ln 46 divided by 155 divided by 15. Okay, divided by 15. So after finding this rate, we can go back here and then calculate that rate. Let me just calculate that. It's 46 divided by 155 ln of that number. No, 46 divided by 155 ln of that number divided by negative 15. So that's negative 15. So that is the value of k. This is the value of k. Okay, so the k is what is k? This number 0.080, and then so many different values here. 985581, 985581, and keep going. So that's the rate. Now to find out the temperature after 20 minutes, you go back there and then use the same formula. T, this is the formula. T0 is 0, so you don't have to worry about that. It's 155. That's the initial temperature. E minus k, this k. So k times T. T means 20 minutes this time. So when you do the calculation, first multiply this k by 20. And then k is already given here, so do not round it. Just multiply that by 20. And then take the negative of that. And then take the e to the power that number. So I'm just going to copy that. So e, where is e? To the power, and then the number we just calculated, which is that one, negative 1 points, this one. Yeah. And then that is 0.19, and you multiply that by 155 because there is a T1, 155, and that is 30.68 degree. Nearest integer, it's a 31 degree Fahrenheit. 31 degree Fahrenheit. So to answer this question, first of all, you need to find the k by given information, and you put that k again in the function to calculate the value after 20 minutes. Last question. Following the birth of a child, a parent wants to make an initial investment P0 that will grow 50,000 for the child's education. That will grow to 50,000. So this is the future value. At age 19, interest is compounded continuously at 7%. What should the initial investment? Keep in mind the formula is the future value is equal to the initial value times e to the power r times t. This is the compound continuous formula. In this problem, the future value is given, which is they need 50,000. Initial investment, we don't know. The rate is 7%. Time is 19 years because that's the time. So to find the initial investment, just divide 50,000 by this number. So 50,000 divided by this number. Look, 0.0. So how do you do that? Here, type 50,000. Divide that by, okay, 50,000. Divide that by parentheses, and then e to the power, another parenthesis, 0.07 times 19, parenthesis close, another parenthesis, and the answer is $13,223. Do not round until the final answer. This is the final answer. Round to the 2 decimal place. $13,223.86. $13,223 and then 86 cents. That's the amount you need to invest today to have 50,000 in 19 years with a 7% interest rate. 23. Sorry, check the answer. Correct. So that's all for test 4 review.